So this very simple petri net needs to be modified to become a little bit more intelligent and have a proper contingency plan. If we continued using pure petri nets, it would get a bit complicated, and I'll show you why once I've built part of the contingency plan. I'm going to remove this transition and replace it with the beginnings of a contingency plan. Let's take away the transition and move this over slightly so we can see better. There we go. So that transition is, and the arcs indeed are no longer required. We go back to simple two states, which, if we look at it, there we go, two states, two problems modeled, but no way to fix them anymore. We've removed the fix. Now we add the word contingency, and we say we want to convert problems to solutions. Let's see what that does. Wow, it's already built a more complicated petri net than we had before. And this time the states are miniaturized. You see this little state over here. It's been made much smaller because in our contingency plan model we pre-build all the states for you, and they all have very fixed meanings. You see, if you actually touch one of these states, you get the text inside it, in this case fail. If I zoom in a little bit more, you'll see that. So what we've got here is the problems are pulled into a basic test, a default test, which in this case means check it. The red here is check it, and the check is there information in the token? If there is, we fail. Well, if there is information, no, if it is empty, sorry, if it's empty, we pass, go to solutions, and if it is not empty, we fail it and we move to the repair state, and then that repairs. Obviously this is a little bit too simplistic. We don't want to fail it based on the token being empty. We want to fail it based on the word failure. So the first thing we do, we need to interact with this check statement. You'll see there is no check statement here. What you have to do is open a Ruby block of code and make one. Check. Let's say check, we can call it anything we want. We want to check the problem. Alright, is the problem really there? Okay, check the problem. Now we want to modify this test. So we can say pass, sorry, the check should be, it will pass if not containing the word failure. Okay, not failure. So it passes if it's not a failure. Okay, if it's not a failure, it will pass. If I run this, you'll see that since these are failures, they will move this bottom root to the repair and go up there. Let's start it. Well, let's run one step at a time. Make it easier to see by doing this. You'll see that the failure has moved into the fail state. So in other words, we've checked the problem and yes, there is indeed a failure. Fire again and we go to the end. But notice that nothing's changed. The repair action hasn't done anything. So if we want to repair it, we need to also work on the repair action. And let's say repair it. And what we can do is put an expression on this. That was exactly what we already did before. It was a string substitution. We replaced the word failure with fixed. Let's load this again. So now what we can see is the token will be modified by replacing failure with fixed, and we also changed the time setting on it by just saying we modeled it will take 1 time unit to actually perform this fix. We can change that as well by adding further information here like duration 3. Let's say it takes 3 time units to fix that. Let's have a look at what that does. There we go, 3 time units. It automatically positions these things for me, so I don't have to do any layout work at all here. I can, and I'll show you that later, but the contingency plan syntax that we've developed here really tries to do as much for you as possible. And notice that we have exactly the same number of checks, repairs, and states that we had when we specified nothing at all. And that's because if you don't specify at least 1 check and 1 repair, it will build them for you. It will build one of each for you and connect it. If I will add another check and repair after I've made 1 further change. If I run this now, it will modify the failure to fixed, but I would like to see if we can recheck it. So let's recheck it by saying that after doing the repair we want to rerun the check. So what you do is you say on the repair line here, I'm going to put further information. Next is problem. So we go back to this problem one, we've tied it back. Let's have a look at how that looks. Now this is interesting. In fact, in this case it might make more sense to put the these two around like this. Say, check the problem. If it's already solved, go up to solutions. If it's not, go through the failure to repair action and go back to the problem, and now we check it again. Let's fire this. Let's test it out. So the first problem has been checked and it's still in the fail state, network failure. So we'll pass it through the repair action, which is going to replace failure with fixed. Do that. Boom. Now we see we have a network fixed thing here, but it took time to do it. So in fact it took so much time that the disk failure is ready to be fired, so our next one will in fact do the disk failure. That also comes down here. It's also failed. So when we push it through the fixed, we find that they are both fixed, but they're still in the problem state. So we need to check them again. Let's see. Boom. Wow. 2 solutions. That's because this time when we rechecked it, it was found to be fixed. And then the last, bang, there we are. So we have a working contingency plan that shows how you can recheck. You can check a problem, you can repair it, you can recheck it and have it pass on the second round. So this is a reasonable, it's very simplistic obviously, but it is the fundamental root of all contingency plans. So next we will show you how to expand on this and make a more comprehensive contingency plan.